Welcome to Applications of Derivatives, Lesson 3, L'Hopital's rule. And by the time you're done with this, you might just want to go to the hospital. Although, as you notice, there's no S there. There's an S here, but not an S there. But this is L'Hopital's rule. And yes, I know I just spoke some French. L'Hopital was a French guy. Alright, so L'Hopital's rule is a device to be able to make finding limits a little bit easier. Some limits anyway. Rational function limits. So anything that makes rational function limits easier, it's all good with us. So these first three, I don't want you to take notes on them. I just want you to watch. Alright, so the limit as x approaches pi of sine of x over pi over x, sine of pi is 0, so 0 over 0 when replace. So what we're going to do is we are going to take the derivative of sine x, and we're going to make that cosine x. We're going to take the derivative of this function, which is going to be -1, and now we're going to take the limit as x approaches pi. Now we can replace. Cosine of pi is -1 over -1. The limit is 1. Hey, let's try that again. When I replace, I get 9 minus 9 over 3 minus 3, 0 over 0. So we will take the derivative, 2x over the derivative of the denominator, 1. The limit as x approaches 3, that's going to be 6. Alright, the limit as x approaches infinity, we're going to end up with infinity over infinity. So we will take the derivative of both, 1 over x, all over 1. And we are talking about the limit as x approaches infinity. Well, what's 1 over infinity? 0. 0 over 1. The limit, 0. Woohoo! Alright, now we're ready to move on with our notes. I'm going to show you the old way that we did limits and then the new way. First, when we replaced, we see that we get, let's see here, we get infinity over infinity, x squared times 13 times, yeah, okay, this is infinity over infinity. Okay, what we did to try to make this a little bit easier for yourselves before, we would factor and see if we could cancel anything out. And now we're still talking about the limit as x approaches infinity. Whoops, not 0, infinity. Okay. These are both factors, and this is we can actually cancel that because they're factors. Yes, we can do that. So what is the limit as x approaches infinity? It'll end up being infinity. Alright, the new way that we're going to do it is we are going to take the derivative of the numerator, 2x plus 13 over 1. The limit as x approaches infinity. 2 times infinity plus 13, that's a little bit more than infinity, but it would be infinity. Alright, let's try this one. X squared, that would be 16 minus 52 plus 36, that would be 0. And -4 plus 4, 0 over 0. So we can use L'Hopital's rule. Let's take the derivative of the numerator, 2x plus 13 over 1, and we are finding the limit as x approaches -4. So replace 2 times -4, -8 plus 13, 5 is our limit with that using L'Hopital's. Moving right along, when I replace, I get 0 over 0 plus 0, which is 0 over 0. So let's go ahead and take the derivative of the numerator. That's right, cosine x. Take the derivative of the denominator. No, we're not using quotient rule. Derivative numerator, derivative denominator. the bottom. So 1 plus cosine x, and we'll take the limit as x approaches 0. Let's see here, cosine of x, that'd be 1. 1 plus 1. That limit is 1/2. Okay, the old way on this one, the limit as x approaches infinity, what is the horizontal asymptote? 2/3. Let's watch it using L'Hopital's rule. That would be 6x squared over 9x squared minus 1000x. When we replace, we still get infinity over infinity. So we'll do it again. And that would be 12x over 18x minus 1000. And when we replace, we still get infinity over infinity. Take the derivative of numerator and denominator again, we get 12/18, which yields us the 2/3 that we already knew. I just wanted to show you something we've done before and we haven't done before. Alright. The limit as x approaches infinity, that would be infinity over infinity. That does not work real well. So when we replace, we get infinity over infinity. Nice infinity signs, Manning. Thank you. So we will take the derivative of the numerator, e to the x, over 2x, and we still get infinity over infinity. So we'll take the derivative one more time. Derivative of the numerator, e to the 2x. Derivative of the denominator, 2. That would be infinity over 2. That limit is infinity. Okay, this is a one-sided limit because if x is less than 0, hey, wait a minute, wow. We've got 0 times negative infinity when we replace. Well, that's not good. Alright, watch what we're going to do on this. We are going to make this the ln of x over x to the negative 1. The limit as x approaches 0 from the right. And this would be negative infinity over positive infinity. Alright, so since it's negative infinity over positive infinity, we can use L'Hopital's rule. We're going to take the derivative of the numerator, 1 over x. The derivative of ln of x is 1 over x. And the derivative of the denominator, negative 1 times x to the negative 2. Okay, I'll slide this over so you can see what's going on. 1 over x all over negative 1 over x squared. What do you do when you have two fractions? Reciprocate and multiply. 1 over x times negative x squared over 1. These we can cancel. And we end up with negative x. The limit as x approaches 0 from the right, that would be 0. Ooh, that was some algebraic shenanigans. Alright, let's go ahead and look at the next ones. When we replace with infinity, the natural logarithm of infinity is infinity for both of these. So when we replace, we get infinity over infinity. It is definitely a candidate for L'Hopital's rule. So we'll take the derivative of the numerator over the derivative of the denominator. That would be 2x over 3 plus x squared. Alright, we have a fraction. So once again, the limit as x approaches infinity, 1 over x plus 1 times x plus, 3 plus x squared all over 2x. So we've got 3 plus x squared over 2x squared plus 2x. the limit as x approaches infinity. My ears are buzzing because I see the horizontal asymptote. Final answer, 1/2. Okay, how about the limit as x approaches 0, sine x minus 2x? It'd be 0 minus 0 over 1 minus 1. 0 over 0 when we replace, so let's take the derivative. Cosine of x minus 2 all over e to the 3x. The limit as x approaches 0, so that would be 1 minus 2 over 1. That limit, -1. Let's go ahead and move on. How about the limit as x approaches 0 from the right of cosecant x minus cotangent x? As you remember from trig class, cosecant of x is 1 over sine x. Cotangent of x is cosine x over sine x. So we have 1 minus cosine of x all over sine x. And when we find the limit as x approaches 0 from the right, we get 1 minus 1 over 0, 0 over 0. Take the derivative. Sine x over cosine x. The limit as x approaches 0 from the right, that would be 0 over 1. That limit is 0. Whoa, ho, ho, look at this crazy one. All we're going to do is rewrite it as a fraction. This 1 over x, and this is ln of x plus 1 all over 5x. So we're just going to write it the ln of x plus 1 plus 5x all over x. The limit as x approaches infinity. And that would be infinity over infinity. So let's go ahead and use L'Hopital's rule. Derivative of ln of x plus 1 is 1 over x plus 1 plus 5 all over 1, and this is the limit as x approaches infinity. Replace x with infinity. 1 over infinity is 0, plus 5 over 1, that limit is 5. And then the last three that are at the bottom there, we are not going to get to those because you probably will never see those. Watch this be the one year you do. We're just not going to spend, it's not worth the time, it's not worth the effort. So these three here, not going to do right now. So this will conclude Applications of Derivatives Lesson 3, L'Hopital's rule.